1, 0, I, pi, e. Most important constants in mathematics, and each represents a domain. 1. The first number represents natural number domain. We have 1, and then 2, and then 3, 4, 5, 6, 7, 8, 9, and then decimal system. 0 represents real number domain. Arabic numerals was developed in India by around 700 AD. Based on decimal system, add 0, decimal point, positive negative sign form the real numbers domain. Arabic numerals, we are so familiar. Daily routine operations are basically in the real number domain. And important branches of mathematics, including analytic geometry, quadratic equations, and probability statistics, are computed in real number domain. I represent complex number domain. We cannot do some operations in real number domain. For example, square root of -1. So we bring in complex number domain. I is square root of -1. In complex number domain, you can do any basic operations, like square root of -1, arc sine 2. Like this, I to the power of I, you also can do, but actually I don't know what's the meaning of this number. Complex number domain are perfect, but human brain has some difficult to deal with. We are used to one-dimensional numbers, like pi, between 3 and 4, and our brain has an intuitive feeling. If it's 1 plus I, we feel weird. In daily life, we generally use natural number or real number domains. But in the high-end fields, such as quantum physics, using complex number domain. Pi represents circle and trigonometry domain. Circle is too common in the universe. Most of the celestial bodies are round, and every day we can see that the sun is round. The orbit of the celestial body is circle or ellipse. Human-made circular objects, we don't know which one is the earliest. Maybe someone pinched a piece of mud into a rounded shape. Really circular object, it should be pottery making. Later, we use the rounder log to make wheel, so we are more interested about circle. Before 2000 BC, we already knew circle has a constant ratio of its circumference to its diameter. It's pi, estimated about 3.1 in ancient Egyptian. Ancient Greek Archimedes calculated pi equals 3.14 by mathematical methods. Chinese decimal system is a place value system, more advanced compared to ancient Greece. Then, in 263 AD, Liu Hui calculated pi equals 3.1416. In 466 AD, Zhu Congzhi calculated pi equals 3.1415926. Astronomy and navigation calculation need trigonometry. The projection of a circular motion on the x-axis or y-axis is a sine wave. from water wave, sound wave, electromagnetic wave, to quantum physics wave function, huge string theory, sine wave is everywhere. E represents calculus domain. What's the constant E? Let's see an example. Suppose 1 year's interest is 100%. Save $1. 1 year later, you can get $2. If we turn the linear growth of interest rates into exponential growth, the exponential growth means compound interest. How much can we get? If we calculate interest every month based on linear growth, interest per month is 1 in 12. 1 year later, we get 2.613. If we calculate interest every day based on linear growth, interest per day is 1 in 365. 1 year later, we get 2.714. Actually, usual loans often use. They will say annual interest is 100%, but need to pay interest every month. 1 year later, they can get 2.613 times of loan money. Stockbroker website also use. They will say annual interest is 10%, but need to pay interest every day. The real annual interest is 10.5%. If we divide more, we can get higher interest rates. In 1683, Jacob Bernoulli studied this problem. He found that this sequence approaches a limit with larger n. That's the constant E. Initially, we don't think the constant E is important. It's just an interesting number. Later, Leibniz studied calculus, found that e to the power of x differential function is e to the power of x same. So, how important calculus is, and how important E is. What is calculus? Calculus includes differential calculus and integral calculus. For example, differential study the trend of changes. Integral study the accumulation of changes. The change of speed is acceleration. That is to say, the acceleration function is the differential of speed function. The accumulation of speed in a period of time is displacement. That is to say, the displacement function is the integral of speed function. And this integral of all lengths is area. Integral of all plane is volume. This is integral. The first is differential. Simple example. Free fall. Gravity acceleration is g. Speed is this area. Is gt. Displacement is this area. Is half gt squared. This is simple. Everyone can do it. Why do we need a calculus? Another example. Sphere volume. Integral of loss of circle plane. This is quadratic function. Not easy to calculate this area. If we using calculus, we can calculate sphere volume in 1 minute. Otherwise, if we use geometric method, horrible. In real life, there are many more complicated functions, like hydrodynamics. With broadcasting, always encounter higher order function. Without calculus, no engineering physics. We finish up with Euler's equation. Thank you.